All right, like I said, this lesson should not take very long. And it's kind of similar to what we've been doing. Now, this says we're applying congruence postulates, but what we're doing right now is not really a postulate, it's actually a theorem. Somebody tell me what the difference between a theorem is and a postulate. You solve it? Not solve it. A postulate is just accepted fact. What can you do with a theorem, Justin? Prove it. Prove it is what you're thinking of. That's probably what you're thinking of, okay? So it's not solve it, but you could prove a theorem. We're not really going to prove it in here. We're a little bit short of time anyway, but let's just talk about it. So let's get a triangle. Let's grab a triangle from over here. Let's grab this one. And we'll put it right here. Let's change the shape just a little bit. Just make it a little easier to write on. I'm going to copy and paste it. So if I copy and pasted it, what do you think is true about them? They're congruent to each other. Good. Okay. So now, we've had two ways to prove triangles congruent to each other. This is going to be our third way. What were the first two? We spent a lot of time going over the homework, talking about it. What were the first two? Give me one of them. Side, angle, side. What was the second one? Angle, side, angle. So on side, angle, side, what had to be true about the angle? Had to be where? Yeah, in the middle, but between the two sides. Or what word did I introduce today? It's got to be the what? Included side. Remember that? Or in this case, the included angle. It means it's between it. What was the other one? Side, angle, side, and angle, side, angle. Look at that side right there. What is that side? It's what? It's the included side. Everybody got that? All right, so that's the included side. What we're going to do today is we're going to deal with something that's non-included. All right? It's going to be a side that's not included. So here's what they give you. They give you that this angle is equal to this angle. Everybody watching? And they're going to give you this angle, angle C, equals angle F. But watch. They're not going to tell you that BC equals the EF. What they're going to do is they're going to give you one of the other sides. They're going to give you AC is equal to DF. So this is not angle side angle, is it? Why is this not angle side angle? You're like, Mr. Henry, you said just a minute ago that if you got two sides or two angles and a side, that's angle side angle. But this side is not the included side. It's not in between those two angles. So take a wild guess. It shouldn't be too wild. It should be a pretty easy guess on what you think we're going to call this thing. You got it. I knew somebody would get it. Okay? We call this the angle side. And this is not a postulate. We don't just accept this as fact. This is actually a theorem, and we could prove this. I'll tell you, we got a couple minutes. Let's talk about this just a second. I didn't do it in the last class, but I only got one head down, so I got a good start here. So let's take a look at this. If I have two angles of a triangle equaling two angles of another triangle, what do you think must also be true about A and D? Like if this was 30 and this was 70, what would this be? If this is 30 and 70, 30 and 70 is 30 and 70. What's 30 and 70? 100. So what's this angle right here? It's not 40. What do they add up to be? They don't add up to be 140. They add up to be 180. So if this is 30, guys are scaring me. If this was 30 and this was 70, what's this angle right here going to be? It's going to be what? Say it. 80. Thank you. All right. So look, these two are the same. Everybody look. Everybody look. These two are the same as these two. So this would be 30 and 70. So this would be what? 80. You follow me? So if these two angles equal these two angles, what must be true about the third angles? They got to equal each other as well, correct? So watch this. This is kind of a proof. It's a very simplified proof, but it's basically a proof. So I know that these two angles are equal to each other right here. Now, what could I use? I could use a postulate. See, it says applying congruence postulates. This is where we apply it, because I know that these two angles must be equal. So now, why are these triangles congruent? Let's say you didn't know angle, angle, side. How would you know that these triangles are congruent now? Because of angle, side, angle. Very good. Angle, side, angle. That's your proof. So these triangles are, even without this, I could have figured out that this angle and this angle were equal to each other. Then I could have said, oh, if those two angles are equal, then these two triangles are congruent. Why? Because of angle, side, angle. You with me on that? But I don't have to go through all that mess. Okay? All I got to do is look at this and say, okay, I got two angles and a non-included side. That automatically makes these triangles what? Congruent. Why? Because of angle, angle, side. All right, if you didn't understand that, it's not that big of a deal. Just know that if I have two angles and a non-included side, those triangles can be congruent. Okay? Not can be, they would be. Right? What if I did this? What if I said that this side was equal to this side? Is that still angle, angle, side? Yeah, we don't go side, angle, angle. I don't know why they don't do that. I think they just go in alphabetical order maybe, put the angle first, okay? But we always say angle, angle, side. We never say side, angle, angle. So you still have what? An angle, and a non-included side, right? It's not in between. What if it was in between? We'd call it angle, side, angle. If it's not in between, if it's not included, that's what we call it. If it's not included, we call it what? Angle, angle, side. All right, so these triangles are congruent because of angle, angle, side. Make sense? All right. Got one more thing. Well, it's kind of two things. No, I don't want that triangle. Let's do this. Let me grab this triangle. I'm going to make it look a little bit different. And let's make it look like this. All right, there we go. There we go. All right, so I'm not comparing two triangles this time. Here's what I'm going to do. I'm going to take one triangle, and I'm going to look at some stuff that they give us. Everybody watch. We got two more things. We got this, and then one that looks almost identical to it. All right, watch. What if I told you that this angle and this angle were equal to each other? Let's call it ABC. Might as well. All right. Sounds like it. So watch. If I got these two angles equal to each other, we have a thing. Oh, by the way, I'm sorry. A, B, C. I want to do it the other way. I want to start with this one first. I'll eventually get to that, but not right now. Okay. All right. I got two sides of a triangle equal to each other. We have a name for that. We talked about that, I think, last week. What do we call a triangle that has two equal sides? I, S. I'm really glad you guys listen to what I say. Isosceles. I'd say isosceles. So this is called an isosceles triangle. And what we're going to talk about right now is called the isosceles triangle theorem. All right? So here's what it says. Everybody watching? It says, if I have a triangle with two equal sides, that means I got an isosceles triangle. The theorem says that the angles opposite those equal sides are also going to be equal to each other. So what does that mean? If these two sides are equal, the angles opposite those sides are also going to be equal to each other, which is what? B and C. Very good. So B and C would also be equal to each other, okay? So this basically says if AB equals AC, then what? Angle B must equal angle C. You with me on that? Okay? What if we go the opposite way? What if I said, oops, come on, just grab that thing. Okay. What if I told you that angle B and angle C were equal to each other? Now that's different than the last one I did. What did I tell you was equal the last time? The two sides. Okay, this time I'm telling you the two angles are equal to each other. All right? What do you think? Watch. So if angle B equals angle C, then what do you think might be true? If these two angles are equal, what else do you think might be equal in this triangle? The two sides are equal, exactly. So that means if these two angles are equal, then these two sides are equal. Okay, so if angle B equals angle C, then what? AB must equal AC. Do you see how they're kind of reversed? Do you see that? Okay, this is called the converse. Okay, when we reverse it like that, we call it the converse of the what? Isosceles triangle theorem. So the isosceles triangle theorem says you start off with two equal sides, the two angles opposite are going to equal. The converse does it the other way. It says if you start off with two equal angles, then guess what? The two sides are going to be equal to each other. Make sense? So for instance, what if this was 70 degrees and this was 70 degrees, and I said the length of AB was 5, and I asked you to find the length of AC? What would you do? It's just 5, that's right. If these two angles are equal, these two sides are equal. If this is already 5, what's this going to be? That's going to be 5 as well, okay? I might do something like this. Might say this is like x plus 2. So here's the information I give you. I give you these two angles are equal to each other. Actually, I probably would not tell you that the sides are equal to each other. Okay, here's the information. I give you these two angles are equal. I say this is x plus 2. I say this is 5. I want you to solve for x. So how would I solve for x? It's not x2. X plus 2 equals 5. That's right. That's right. You're exactly right. These two angles make these two sides equal to each other. All right, so this equals this. So x plus 2 equals 5. Subtract 2 from both sides. What's x equal to? 3. So x is equal to 3. That's the kind of stuff that they're going to ask you to do with this. All right? So you got to know if these two angles are equal, these two sides are equal. Or if these two sides are equal, then what? These two angles are equal. You got it? What if they did this? We got a minute here. What if I told you that this was 5 and this was 5, and I told you that that was 70, but I did not tell you this angle down here, but I want you to find angle A. Find angle A. This angle right there. How would you find that angle with this information? Look at it. Let's think. Let's think a little bit. So these two sides are equal, so that means what? The two angles are equal. So if this is 70, then what's this? That's 70. How do I find angle A now? Add them up. That's what? 140. Take it away from 180. What's 180 minus 140? It's 40, so what's angle A? It's 40 degrees. See how it all works? That's the kind of stuff that they're going to ask you to do. All right. So I gave you your lesson plans yesterday, but I'll write it down again. So it's section 4.4. It's numbers 1 to 12 and 18 and 19. Is that what I gave you yesterday? Anybody want to check? It's pages 172, 173. All right, that's your homework. So please, if you have not been doing your homework, you've been getting zeros. All right, just so you know. If you haven't been turning it in. All right, if you do your homework, you'll get some points for it. All right, so that's your next homework assignment. I want everybody to get a 5 on this. So everybody, do your homework. Come in tomorrow with it ready to go.